Hi everyone, thanks for coming. So my name's Kimberly, and at the moment I'm doing my PhD at Adelaide Uni, and I'm looking at how important planting arrangement is within revegetated sites. So I'm looking at the fine scale, so the arrangement of plants actually within those sites. So this probably follows on quite well from Randall's talk, because I just happen to be one of Dave Payton's students that's working out at Monarto. So in natural systems, planting arrangements occur for a number of reasons, and that results from broad-scale environmental factors such as climate and topography, also disturbance history, down to fine-scale factors such as plant-plant interactions, so looking at competition and facilitation between plants, and seed dispersal. So these factors can influence things such as population density, population size, distances between individuals, aggregation, and also community composition. And these arrangements are important because they affect the processes that occur within those sites. So they can affect pollination, they can also affect competition and facilitation between plants, and plant growth. But at this stage, when revegetation is done, these natural plant arrangements are often overlooked. So revegetation is often done in quite a haphazard way, but no research has really looked into what effect this has and if it affects the processes that are occurring in those sites. So I'm looking at how does planting arrangement affect ecological processes. Specifically, I'm looking at how it affects pollination and seed production. So I suppose the overall reason for this was that if revegetated systems aren't reproducing that well, they might not be able to become self-sustaining. So if that happens, then we're going to have to go in and replant once that original population dies out. So as I was saying, I'm working at the Monarto revegetation area. So this area was revegetated in the 1970s by the Government of South Australia. It's the largest revegetation project in the state, so it's about 2,000 hectares in size, and it was planted in evenly spaced straight lines, and those are about 4 to 6 metres apart. So as you can see here, the planting arrangement is still pretty obvious. Those lines are still quite evident. So there was over 250 different species used in this site. A lot of those were Western Australian species, but overall the plantings are dominated by Eucalyptus. So I've chosen Eucalyptus leucoxylon, which is also known as the South Australian blue gum, for my research. It's widely used in revegetation across southern Australia, and it occurs naturally in the Monarto region. So at Monarto it was planted a range of densities, so from about 1 to 35 trees per hectare, but the overall planting density remains pretty consistent. It's just the density of, I suppose, my focal species that's changing within this site. So firstly, I decided to look at how seed production is influenced by population density. So to do this, I selected about 100 study trees and collected fruit material from them, so the gum nuts, and then I GPSed the position of any other blue gums within 100 metres from that, and that's how I got the density. So what I expected was for the number of seeds per fruit to increase linearly with density as the number of potential mates increased, or I expected it to reach a certain density where it would plateau off. But this is what I found. So as you can see, there's not really much of a trend with density and seed production. And it actually occurs that the individual that produced the highest number of seeds was actually this one, which occurs at a relatively low density. But I wasn't convinced that arrangement wasn't having a role at all out in this system. So I decided to look at these ones here, which are all doing really well. And what I found was that regardless of the density, these individuals had another individual at 20 metres, or 20 metres or less, sorry. So instead I decided to look at, okay, how is seed production influenced by the distance to the next blue gum? And this is what I found. So there was this peak in seed production when there was another blue gum at 20 metres or less. So even though there was a lot of variability in seed production, and having another blue gum close by, I suppose, doesn't guarantee that there's going to be seed production, high seed production, there is this drop-off as that distance increases. So this made me ask the question, well, okay, is it more of a question of aggregation, and should we be planting species in clumps? So the next part of my research looked at aggregated individuals compared to those that are more dispersed. So I classed an aggregated individual as one that had another 5 flowering blue gums within 30 metres, one that was dispersed as having no other blue gums within 30 metres. And this time I also looked at the pollination. So to do that, I tagged branches that had buds on them before the flowering season, and then tracked how many of those were converted to fruit. I also added 2 other treatments. So I had a bag treatment to exclude pollinators, so just to get a measure if there was no pollinators in the system, how many of those buds would be converted. And I also added additional pollen, so just to get an idea of if there was any pollen limitations or not. So what I found was that there wasn't really a huge difference in the aggregated and dispersed individuals. So this first graph, I suppose, is showing this part of the reproductive cycle, so how many of the buds are getting converted into fruit. And this second graph is looking at, okay, of that fruit that was formed, how many seeds are in those fruit. So at the open category, aggregated are doing slightly better than dispersed, but it was only about 5%, and they're only producing about 2 more seeds than the dispersed category on average. But I suppose this is probably the interesting result here. So this suggests that the system is pollen limited. So when I added additional pollen, it doubled the amount of buds that were becoming fruit. So this might explain, I suppose, why there's not a big difference between the aggregated and dispersed individuals. So if there's not enough pollinators out there, it might not really matter how the plants are arranged. The species is also bird pollinated, so I suppose what pollinators are out there might easily be able to cover the 30-metre distance that I'm looking at. And at this stage we don't know what the effect of selfing is, so the dispersed individuals might have higher levels of selfing as well. So what does this mean for revegetation? So at the moment, revegetation guides often suggest, I suppose, like a standard sort of planting density. So some say, okay, for this species it should just be planted at 40 trees per hectare. But we might need to move away from this and consider more of the finer scale arrangement factors, such as distances between individuals. So for the blue gum, planting individuals 20 metres or less apart may improve seed production, but we also need to take into account the needs of plants and their pollinators to try and reduce pollinator limitations. So we need to think about how pollinators move between systems, and also what we can do to attract them to revegetated sites. So I'd just like to thank the following organisations for supporting my research.